Hello everyone, in this video we are going to discuss the modeling of mechanical system. The equation of the motion are generally formulated using Newton's law of the motion. A mechanical system may have either translational motion or rotational motion. In translational motion, motion take place in straight line. In rotational motion, motion will be in rotation. So in translation motion, input will be in force and output will be in displacement. Whereas in rotational motion, input will be in torque and output will be an angular displacement. There are three elements are used in both two motions. Mass, spring, dashpot are the three elements of the translational motion. It can be denoted as M, K and B. In rotational motion, spring and dashpot is common for rotational motion and mass can be replaced with moment of inertia. It is denoted as K. Here the spring is also called as shaft stiffness K and the damper or dashpot is also called as viscous friction coefficient B. Okay. So this is your translational mechanical system elements with time domain and Laplace domain formula. So first one is a mass. The symbol is M. So this is the representation. So input will be, I told you, the input will be an force and output will be an displacement. Here f of t is your input force and x is your displacement x. And m is the mass element. In time domain, f of t equal to mass symbol is m into d square x divided by dt, right? In Laplace domain, same m can be repeated. D square divided by dt square can be replaced with s square and x can be denoted as x of s. And the second one is a spring k. So here f of t is an input and x is an displacement is your output and k is a spring and the time domain formula f of t equal to k into x. So in Laplace domain, time domain can be replaced with s. So f of t can be replaced with f of s equal to k into x can be denoted as x of s. And the third one is a damper or dashpot. So symbol is B. So f of t is your input and x is your output term, so displacement. So f of t equal to b into dx divided by dt. So in Laplace domain, f of s equal to b into d by dt can be replaced with s. So s into x of s, right? So here mass. So mass can store the translational kinetic energy due to its velocity, while spring store the translational potential energy with its due to its position, and damper or dashpot is capable of dissipating the energy. Okay, so this is your first uh, problem. Write a differential equation for the translational mechanical system as shown in figure. Determine the transfer function, right? So what is transfer function? Because mechanical in topic itself it's a transfer function modeling, right? So mechanical transfer function model. So what is transfer function? Laplace transform of output divided by Laplace transform of the input. Am I right? So here force Laplace transform f of t is your input term. So two displacements are given. So what are the displacement? X1 and x, right? So x of 1 and x of x. So here x is then output term. So our Laplace transform of output divided by input means x of s divided by f of s. This is your hint, right? So for in first step, we have to draw the free body diagram for the mass element. There are two mass elements are there, m1 and m2. First, we have to draw the free body diagram for the mass element m1, right? So you can draw the block of m1. So how many elements are connected? Look at this diagram. How many elements are connected? K and this one is a B and you can take so B is nothing but your dashpot or damper and the next one is L. So sorry, it's a next one is a spring K. Okay, so f of k, f of k1, next f of b and f of k and your mass element f of m1. So look at this diagram. Either apart from the k, b, k1, the b1 also connected. b1 is indirectly connected. So b1 is nothing but your damper, right? So f of k1, f of b1, f of m1 mass element and f of b is a damper or dashpot, f of k is a spring, right? So two springs are connected to m1, right? So look at this diagram. This spring and dashpot is common for both m1 and m2, right? So here you have to apply the So you should apply the KVL law similarly. Okay. So first we should apply the Newton's second law. Sum of the applying force equal, what is this Newton's second law? Sum of the applying force equal to sum of the opposing force, right? Here there is no force element, so equal to 0. Applying force is 0. In opposing force we are just writing how many elements are connected. So how many elements are connected? K1, B, K, M, and B1 is indirectly connected. So 5 elements are connected. Here I am writing that 5 element equal to applying force is 0. And then I am writing the differential equation or time domain equation for these elements. So M formula is M into d square x divided by dt. Here mass element is M1 and displacement is x1, right? So x1 plus f of b. So formula is b into d by dx by dt. So look at this diagram, this b, this one is a b. I forgot to mention that symbol, guys. Okay, so here b is common for both m1 and m2, right? So here m1 displacement is x1, m2 displacement is x. So I'm writing d by dt into, here I'm applying the Kirchhoff voltage law. So x1 minus x plus k into, so this k also common for both m1 and m2, right? So k is nothing but a spring. So I am writing k x1 minus x plus, next one is a k1 term. So k1 is connected to m1 only. So I am writing k1 of x plus b1. b1 is indirectly connected to m1, but it only connected to m1, right? So b1 into dx1 divided by dt equal to 0. Next I am going to taking the Laplace transform on both sides. So here d square divided by dt square can be replaced with s square and x1 can be written as x1 of s, right? Similarly I am writing this whole equation for this. So at the next step I'm taking x1 of s as a common term. So and then x of s as a common term. Finally I can get this equation. So I'm taking x1 of s in the left side and then I'm converting remaining terms into my right side. Finally I got x1 of s value. So next I'm gonna draw the free body diagram for the mass element m2. So look at this diagram, how many elements are connected? This one is a b and this one is k and f of t, and b2 also connected, and f of m2. So 1 2, f of b2 is 3, f of m2 is 4, and f of t is 5. Here also 5 elements are connected. That's what I'm mentioning here. Next I'm gonna applying the Kirchhoff's voltage. So I'm gonna applying the Newton's third law. Sorry guys, Newton's third law. So sum of the applying force equal to sum of the opposing force. So here the force element is connected in mass element m2. So f of t equal to f of m2, f of k plus f of b f plus f of b2. So next I'm gonna applying this time domain formula for this element, and I'm gonna taking the Laplace transform for this equation. So the t can be replaced with the s. T square divided by dt square can be replaced with s square. So m2 s square into x can be written as x of s. Similarly I am writing the Laplace transform for the entire equation. So k into x can be written as x of s minus x1 of s plus b. D by dt can be replaced with s, and x minus x1 can be written as x of s minus x1 of s, right? So next I'm gonna taking the x of s as a common term and x1 as a x1. So here next step I'm gonna substitute in the x1 value. So after the substitution I'm taking the x of s as a common term because it's x of s common for both two elements after substitution of x1 of s. So I'm getting this equation. So what is the transfer function, guys? I told you right in before starting the problem I told you transfer function is nothing but Laplace transform of the output divided by Laplace transform of the input, right? So x of s is here in output term and f of s is my input term. So I'm changing the f of s in my right side and the entire equation in my left side. So what we got, x of s divided by f of s equal to, here I am taking the cross multiplication. So m2 s square plus b2 sb, because here we have a denominator, here we don't have a denominator. So I am applying the cross multiplication. So m2 s square plus b2s plus bs plus k minus of m1 s square k1 plus k b1 plus b into s minus bs plus k divided by my denominator term, right? So I am converting this one in my right left side, and f of s in my right side. So what we got, so we get then reciprocal term, right? Because I'm converting this one into my left side. So denominator term come first, so it will be in numerator, and numerator term will be in denominator, right? So this is my transfer function of the mechanical system.